In this video, I'll be explaining a few of the more advanced concepts of Source 2 mapping. I'm going to be going over VIS and lighting in depth and quite a lot of other things. I've been wanting to make this video for a while now, but I've been very busy working on Star by Star Gaming's new Garry's Mod roleplay map, RP Hogsmeade SBS, which you can learn more about at the links in the description. I may even do some map development videos in the future. Another future series I plan on doing is a full Half-Life Alyx playthrough where I do a commentary over the commentary. I'll be playing with the developer commentary on and giving my own commentary in lieu of the window room video I made previously, and maybe I'll do a challenge like pistol only. So before I begin, I want to tell everyone to go check out Hosomi's YouTube channel. He does a lot of short and to the point videos about the new features of Source 2. Very useful stuff. Go check out his tile mesh video. That's probably my favorite feature of Source 2 right now. And another place you should check out is the mapcore forums right here, the Source 2 section specifically. Now, it might not be very active right now, but I suspect in the future that if we get Counter-Strike Source 2, that this is going to be the place to go. Till then, mapcore is still one of the best source engine forums that still exists. So since my last video, Half-Life Alyx and its development tools were released. I'll be using Half-Life Alyx for any future videos on Source 2 unless something like CSS2 or Gmod 2 comes out. But first, I'll quickly show you how to install and launch the Half-Life Alyx development tools. You just right-click and go to Properties, and then under DLC, you check the box next to Workshop Tools, and the Workshop Tools will begin to download and install. Now, each time you go to launch Half-Life Alyx, you'll be asked, do you want to launch the Workshop Tools or not? And you just hit play. Half-Life Alyx allows you to test your maps without a VR headset at all, so as long as you don't check the Enable VR box down here. All you have to do is select or create a new add-on, and then hit Launch Tools. You don't have to do any goofy command line editing now or anything. Where did it go? Where is Hammer? There it is. Why did it open up minimized? So Hammer 2 is slightly different now, but most of the important stuff remains completely the same. I'm going to quickly cover a few little things that I missed or that people brought up in the comments. First of all, Shift-Z maximizes your viewport just like in, normal Hammer, and I don't know how I missed that one because I use it quite a lot. You can hold down right-click, then Shift, and move your mouse in the 3D viewport to pan. You can kind of move up and down by doing this. You can also hold down Alt, then right-click to zoom your camera in on any viewport very finely. I'm not going to cover sound too much in this video, but I will talk about the two basic entities that you'll need. SND event point, and this is the equivalent of the source ambient generic. And there is also SND soundscape, which is, it's the exact same thing as an ENV soundscape. Here is a list of all of the Half-Life Alyx soundscapes. You can pause the video. Just kidding, I'll put a link to this text file in the description. Another thing I'll quickly talk about is how to make a nav mesh. It's very simple. All you have to do is go up to your navigation button up here, which is new. You can access it by hitting 8 on your keyboard. Click Create Walkable Speed and dragging a cube, and that's it. Now you can hit Nav Preview, and that is the nav mesh that the game will generate. If you want to have more stuff covered by that, so say like up here this level doesn't have, the nav mesh, well, you just make a new block, and there you go. You can nav preview again. Now you can get way more advanced with that, but I'm not going to cover that. So there's no actual water in Source 2 at all. Hopefully one day we'll get a game in the future where we have our underwater gameplay back, but right now you can simply mimic the effect of water with like animated bump map materials, and I'll cover that in a future video. There's also a cool add-on in the workshop that has very cool looking water. The entity logic system in Source 2 is basically the exact same, but it has a few more extra things like map relays and map variables, and these are pretty cool and might come in handy one day. The entity report, which you can open with Control-Alt-R, is way more advanced than it was in Source. It's got all kinds of options you can go through and sort by and find entities in your map. Speaking of entities, when it comes to brush entities, you should always work in object mode when tying them to an entity. Occasionally you'll have situations where changes made in mesh mode may not carry over to the actual entity. Make hollow is gone, but not forgotten, because now in Source 2 you can just go into the face edit mode and hit F, and it will flip all of the outward facing faces inward. This isn't really a good material to use, but now you can see they're inward facing. You can flip them back and forth. When it comes to general mesh design, it seems like most of the Half-Life Alyx maps actually split up their meshes by texture. They also split them by Cubemap, since you can only have one Cubemap active on a surface at a time. Source 2, unlike Source, does not require sealed levels, and in fact, there are holes in these retail levels, like right here. So meshes in Source 2 work kind of like how they would in 3ds Max, where a mesh is like a master object. And here, if I go into mesh mode, this is all one mesh, but we have two solid bodies, I'll call them, and you really shouldn't do that. You should separate these into two different components. And you can easily do that by right-clicking, going to Selected Meshes, and hitting Separate Mesh Components, or pressing Alt-N. That will turn this into two different meshes. You can do the same thing with faces. Like I said, the retail maps like to split up the map into kind of textures or cube maps. So you can just take this face that's part of a mesh, and you can do the same thing, Alt-N, and now it's its own mesh, separate from this. You can recombine them by having multiple meshes selected and merging them, or pressing M. Speaking of retail levels, the retail levels themselves, which can be found in the Half-Life Alyx content HLVR maps folder in the release folder, you can find all of the retail maps here, and you can learn from them and check them out. And I highly suggest you look at these because you can figure out pretty much everything from this. Here's a retail level. So at the end of my previous video, I had kind of a conundrum. I was wondering, how do you make like complex geometry? Like, how do I make a cylinder intersect another cylinder but correctly and make it clean? Well, I haven't figured that out yet, but luckily Source 2 allows you to just import industry standard mesh formats. That's right, I can go to my 3ds Max export folder and import bentthing.fbx, and it will be somewhere in the map. There it is. And so I have bentthing, and I can assign it a texture, and look at that. It's a fully editable mesh in Source 2 that I just imported, and I created this with 3ds Max. You can also export geometry from Hammer with the export selected, and you can export as FBX, OBJ, or DMX. In another video I made, I confirmed that a Source 2 unit is now 100% represented by 1 unit equals 1 inch. Unlike in Source, where almost all of the art was made with 1 unit equals 1/16 of a foot, your player height when not in VR will always be 6 foot, with your eye level being slightly lower at 64 units. Your player height will be near to your real-life height when playing in VR, so it's still pretty important to design your levels around ASA and NFPA building codes. In Source, you can no-clip right past the world border. No problem. But you really can't build anything past it, at least easily, in Hammer. So here's a brush, and now it's like, you can't even select it unless you select it directly. Don't do it. You can't even build right up against the world border. But Source 2 is the exact opposite. In Source 2, there is a hard, fast barrier that I will call the firmament that makes traversal beyond the wall impossible. And I'll show the console here. Oh, and here's a side note. If you're ever alt-tabbing in and out of Half-Life Alyx and you see your cursor and your camera isn't really moving, just hit escape. So you can now see the console calls. However, in Source 2, you can easily build out of bounds. It's no problem. Everything works outside of the grid. In fact, even lighting and viz calculations seem to work just fine outside of the grid, as you can see. NPCs typically will just teleport themselves to the nearest navigatable area, but this one seems to be hanging out outside of the world border today. Oh, there he goes. He must have been stuck in between. So I believe in the future it might be possible for a game to, like Operation Fishbowl, break through the firmament and allow the player traversal beyond the wall. Not that you should need any more space, as the Hammer grid even today, for today's video games, is plenty big, and larger maps now take a lot longer to compile. More on that later. But why am I even talking about building out of bounds anyway? Well, whenever you have a large level that gets near the world border, it makes building a 3D skybox extremely easy if you can build out of bounds. Which leads me on to my next topic, 3D skybox creation. So creating a 3D skybox in Source 2 is very similar to Source, but with a few changes. The main difference now is that 3D skyboxes are no longer part of the main level, but they're their own unique level that gets loaded on top of the main level. 3D skyboxes also have their own independent lighting and sky settings. So to make a 3D skybox, I'm going to first copy our lighting and sky settings from our main map, and then I'm going to create a new map and paste them in. Now I'll create a new entity, a sky_camera, just like in Source, and I'll make sure the origin point is set to 0, 0, 0 in the transform. I also like to select the transform lock checkbox, so that way I don't accidentally move it around later on. This is where you also can set your 3D skybox scale. It's defaulted at 16, just like in Source. 3D skybox fog apparently acts the same way as it does in Source, although I'm not quite sure about this. The retail levels seem to use it, but the effect isn't visible all the time. The last thing you need to do is go up to Map, Map Properties, and set your map type to a 3D skybox. Now let's just add something. I'll build something over by where we were at. I'm actually going to go and set the sky camera to use 1 for the scaling because I built it over there. And at 16 scaling, it'll be way far away from where we're at. So back in our main map, to add the 3D skybox we just made, all we have to do is add a new entity, a skybox_reference, and we'll put this at 0, 0, 0, just like our sky camera, and I'll also lock it. Now under map name, we just go and find the outgrid sky map we just made, and now when we look around, you can see there's our skybox. Now this will not yet work because the skybox actually needs to be compiled independently from the main map. Alright, so that's done. Now we can compile our main map, and when this is finished, we'll see that we have our 3D skybox in our actual level. Alright, so now in the level, whoa, we have our 3D skybox. And it's as easy as that. Another thing I'll quickly mention is that if your 3D skybox becomes annoying in the editor, you can simply hide your skybox reference or put it on a Viz group. That way you don't see it while you're working around your map. So say you have a level with a 3D skybox and you want to test different lighting angles and settings. It would be really annoying to have to go and change the settings here and then copy them over to your skybox. You would have to compile your skybox every time you make a new change, but you don't have to do this because you can use a prefab to do it for you. In Hammer 1, a prefab is simply a group of objects that can be placed into a level, kind of like a stamp. It can be useful for creating many small, unique things, but once a prefab is placed into the map, it's part of that map. If I go and change the original prefab file, say we'll change the material here, and save it, the maps that use that prefab are not updated, but new prefabs will be. But in Source 2, prefabs work a lot more like instances in Source. In Source 2, a prefab is a completely separate map file that can be placed into another level. But now, changes made to that prefab file will propagate to all maps that use the prefab. Valve makes heavy use of prefabs for their maps. In fact, most of this level is entirely made up of prefabs. You can, of course, collapse a prefab into your map, and it will make it unique and not affected by the original map file. As I said earlier, this is basically the exact way that instances work in Source. Here you can see part of my new Hogsmeade map, which I design all of my parts as instances themselves, but I like to keep all of the environment settings the same throughout each map by using an instance right here. Here you can see this is my instance. Let's just add another cube map and save it, and now it's automatically updated to any map that uses that instance. Now Source 2 has something called instances, but they work in a little bit of a different way. In Source 2, instances are not separate files. They are completely local to your map that you're working on. But they share a very similar idea as prefabs do, or instances in Source. For example, let's say you wanted to make, like, I don't know, a street light. So let's make a street light. We'll start with the prop. Yeah, that works. Street lamp on. Spotlight here. Put this up here, rotate it. And now we'll make a little cylinder. And here's our street light. It's kind of very ugly, but I just want it for demonstration purposes. So you make an instance by selecting your group of objects. Then you can right-click, go to Selected Objects, and then hit Create Instance or use Control-Shift-G. So we can go and copy this around the map. So now we have a bunch of streetlights. So let's say, this streetlight's really ugly. You can edit the instance by double-clicking it, and that will allow you to edit the individual components of an instance. So let's scale this down by quite a lot to make it look a lot less ugly. And as you can see, going back into our main map by either hitting backspace or pressing this up here, all of the instances have been modified at once. Apparently using instances in Source 2 will also allow for things to render in batches, which should technically reduce draw calls and theoretically improve FPS. There's one other way of placing other maps within maps that is a new feature of Source 2 called map extensions. This basically allows you to place one map into this map, and it's exactly what I used to make the barrel video. Go check that out if you haven't seen it. To do this, and I like to refer to it as patching a map, you create a new file and you go to Prefabs, Import Prefab. We're going to select the map that we want to patch, so I'm going to patch Outgrid 2. Now I'm going to select the prefab, make sure it's at 000. I'm going to lock the transform and then check Editor Only. This means that it won't actually compile as part of this map. This is just a reference, so that way you can see what you're doing. Now within this map, I'm going to create a box with, I don't know, a head crab on it. And I'm going to save mine as outgrid underscore patch. And let's add a little light on it too, why not? So now I'm going to compile this, and I'm not going to load it in the engine. I'm just going to build it. Now that this is compiled, we need to actually enable our map extension. So to do this, we need to close out our tools, because I don't think there's a way of getting back to the launcher. You need to get to the launcher. So we relaunch our tools, and you hit this gear and go to Edit Add-on Info. Under Map Extensions, let's create a new extension. So our parent map, I think, is called Outgrid 2, and then our extension map is outgrid underscore patch. Now let's launch our tools, and with the console, I'll go and just do Add-on Tools Map Outgrid 2. As you can see, our object is in our map, but you can also see it's black. Now why is that? That's because lighting in the parent map can't affect lighting in the extension, and vice versa. So only this top face is lit because we only put that one little light on top of it. This is really good for doing things like adding custom weapons at the start of a level or something. As you can see, it's also messing with Viz quite a lot for whatever reason. So this cube has its own Viz around it, and it's confusing the main map. You should probably turn Viz off whenever you're doing map extensions, unless you know what you're doing or you're making a more substantial change to the map. I'm now going to move on to the more complex and in-depth parts of the video, starting with the Viz system. Source 2 still maintains some of the basic concepts that existed in Source. Both of them split up the level into little chunks and then compute the lines of sight between those chunks. In Source, all of the world geometry contributes to the Viz calculations, so complex objects like this are typically made into func details. This is to reduce compile times and to also sometimes reduce unwanted results in game. And as you can see, this non-func detail has split the Viz leaves up into a bunch of chunks. In this one over here, we only have one chunk. Source 2 acts in a kind of a similar way, but now there are no func details. Instead, something that you'd want to be excluded from the Viz calculation, you would just open its object properties and select Exclude from Viz. This is the equivalent of creating a func detail in Source. In Source, well-optimized maps typically make use of lots of areaportals and occluders. Well, in Source 2, any mesh, including static props, can be used as Vis Occluders. Vis Occluders can't be excluded from Vis, or else they won't be used as occluders. It's probably a good idea to make most large solid props be occluders. Areaportals, on the other hand, do not seem to exist in the same way in Source 2 as they did in Source, which makes a lot of sense because the new Viz system is a lot more granular and works by figuring out what you are looking at, not just where you are as it is in Source 1. Source 2 almost works as if you're always looking through an areaportal. Source 2 does, however, have a new entity called a VisBox. A VisBox is a volume entity that allows you to fully hide all Viz clusters either within or outside of its bounds. These boxes can be named and can be enabled or disabled on the fly through game logic to show or hide the geometry. In this example, I have 3 identical areas, each with a VisBox inside. The box in the middle has an enabled VisBox set to hide everything inside of it. The box on the left is set to enable and disable every 5 seconds. And the box on the right is a disabled VisBox set to hide everything not inside of it. I'll now enable that VisBox by using the entfire command. Now this VisBox is enabled, and you can see everything that isn't inside of it is hidden. The other geometry you can see is there for an unknown reason. Viz should be hiding these partial meshes, especially when you're inside of a Viz cluster that has no line of sight to the cluster containing that geometry. This is not actually an issue with the VisBox itself. As you can see when I disable and turn on wireframe, you can see in here there's still geometry that's being rendered that shouldn't be being rendered. This may be a bug or some undocumented behavior, or maybe it's how the new Viz system works, or maybe it's even a leak. We can visualize this further though by using the vis_debug_show command. Now this will show us all of the Viz leafs in our entire map. This by itself isn't very useful because you can load this in the editor and it runs a lot better, but there are a few more commands you need to know. Visdebuglock will lock the current Viz state to where your camera was when you ran the command. This lets you inspect from different angles what exactly is being rendered and called by Viz. The red cluster here is the cluster that your camera was in when you ran the command. You can move to a new area and run the command visdebugfindLOS. This will display all the lines of sight between your current Viz cluster and the Viz cluster that your camera was in. So using this, we can prove that this phantom geometry, found 0 lines of sight, should not be being rendered. Now I still believe this is a Viz related bug, and that's because I can pretty much fix the problem by using a visblocker. What's a visblocker? Well, it's simply a brush with the visblocker tool texture applied to it. A visblocker will go and it will destroy lines of sight between Viz clusters, but it will not actually remove Viz clusters themselves. And now, as you can see, when we go into this room, I can no longer see the phantom geometry over there. Now this doesn't fix the problem completely, because in this room I can still see some phantom geometry that would not be blocked by the visblocker, which runs down this path. But everything on this side, I can't see through it, and everything over here, I can't see over to there. Over here I have a room separated by a visblocker in the middle. In game, when I go to this room, I'm unable to see the other side of the room from each side. As you can see, that box disappears, and on this side, half the wall disappears. When I'm inside of the visblocker, you can see everything. So this means when you're inside of a visblocker mesh, it basically disables Viz. So you should always keep your visblockers out of playable spaces. So let's go back to Hammer, and we can go up to Map and hit Load Compiled Viz Data. This will allow you to see all of the Viz clusters in your map in the editor. You can select 2 different Viz clusters and it will show you the lines of sight between them, just like we did in game. Over here I have 4 identical rooms, but the one on the far left is empty minus the prop. The other 3 all contain an entity which is called a visibility hint. This is another volume entity that will help us control Viz. So despite its name, the entity has no relation to the hint tool texture of Source. The visibility hint entity simply allows you to have some control over the size of the viz clusters inside of its volume. It has 3 options: low res, high res, and Z-split. As you can see, the room with the low res grid is all one single viz cluster. The room with the high res grid has quite a lot more viz clusters than the room with no viz hint at all. The Z-axis split room seems to have a few more viz clusters than the empty room, but I've tried this setting in many different configurations, and I can't seem to get it to produce an understandable behavior, but I suspect it may be used for simplifying viz above a certain point. Another volume entity I'd like to cover really quickly is the info call triangles entity. So this doesn't actually have anything to do with viz, but it is a compile time optimization that can remove entire triangles from your map. So for example, I have this large pipe sticking out of the wall in the editor. This would be rendered in-game, but does not need to be, as you can see. The entire pipe is sticking out of the wall even when you're in here. It shouldn't be being rendered. It doesn't need to be. So when you compile your map with actual lighting, info called triangles will physically remove all of the triangles in this volume. And now you can see there's nothing sticking out of the side of the map. And with that, I'm going to start talking a little bit more about how Viz actually works. I'm going to start by creating a new map and then importing a pre-made lighting prefab, and I'll build almost a little mini GM flatgrass, the good version of course. I'll throw in a few models, texture it, and then compile it. Now in game we have our little map, and we can see that as I walk around this platform, Viz is kind of hiding some of these barrels. And even over here, whoa, that's not what we want. So why is it doing this? Well, we can go to map load compiled Viz data and we can see. Viz thinks that the slab is the tallest point of the map and that nothing's going to ever be higher than that slab, since that's the only geometry that it knows about. The topmost face is basically considered a map ceiling, and typically Viz clusters won't generate higher than that. So now let's do something simple and just add some walls around our map. So now our vanishing prop issues are gone, and that's because Viz now has a new ceiling. But if we go and look at the Viz clusters, you notice there's kind of a new issue. The problem is the Viz clusters go up to the walls, but they don't go all the way across the map, meaning that everything within the map isn't going to have proper Viz. To fix this, all I'm going to do is select our edge loop again and hit P to cap the loop. And now I'll go and texture this top face with the Skybox tool texture. The Skybox texture in Source 2 is vastly different than the one in Source. It does not cast light, and it doesn't even have collisions. Its sole purpose is to create empty but valid space. As in, if you were standing and looking at a wall textured with the Skybox texture, a valid line of sight would always be made between you and it, unless there's some sort of includer in the way. The Skybox texture is a lot like just creating a hollow cube, but instead of textured walls, you can see the entire Skybox. You can see now that the entire map has Viz clusters all the way up to the Skybox texture, even in the middle of the map, where they weren't before. I'm now going to delete these walls I just made and create a new, much smaller box using only the Skybox texture around our little platform here. In this situation, the Viz clusters that are generated are quite interesting. So Viz works by trying to figure out what is inside of the level and what isn't. It does this mostly by looking for front faces and back faces. Look how there's an area void of Viz clusters all around the little box I just made. This is the space that Viz is assuming is outside of the level. But because the ground around the box is so large, the areas around the edges are now assumed to be part of the level, since there's no back faces nearby. You can even see the map ceiling concept in effect here as well, since the highest geometry is where all the Viz clusters pretty much cut off. We can't see the barrels unless we step into an area without Viz clusters, which is technically outside of the level and therefore will be rendering a lot more geometry than intended. So just remember that Viz's job is to remove geometry that you aren't actively looking at, so you can run the game on your garbage hardware. You should check out the Half-Life Alyx Viz page on the developer wiki to see a bunch of screenshots of different Viz situations. The next big topic of the video is very rad. That's because it's lighting. The lighting system in Source 2 is extremely powerful, but still maintains some of the simplicity and elegance of the original Source lighting system, with some major upgrades and usability features. In Source, there are a few types of light that exist. you have environment light, which consists of a directional light and a non-directional ambient light. Both of these cast only from the skybox texture. There are simple point lights and spotlights. Both have a direct and indirect component to them. Both point and spotlights can be toggled on and off, but this causes them to lose their indirect component. You can see this really well comparing the non-toggling spotlight to the toggling spotlight over here. These are the same spotlights. You can see the indirect light is bouncing all the way down here. You have projected textures, which allow for really good looking real-time dynamic shadows. Source also uses this for the flashlight, and since I'm in Gary's mod, it allows for quite a lot of these to be active all at once. Finally, you have actual dynamic lights, and these are hardly ever used, but they can create a very interesting effect in the right situations. Source 2, or at least Half-Life Alyx, has only 4 kinds of light entities. You have light omni, light spot, light ortho, and light environment. But each of these have a plethora of options which can create many different kinds of lights. To start, I'll talk about the most basic kind of light, the light environment. The basic settings shown are pretty self-explanatory. You have your color and brightness. The sky tab is where you control your ambient lighting. Don't be fooled by the ambient lighting tab down here. From my experience, this does nothing in-game, but will affect Hammer's lighting preview. To set the real ambient lighting, you need to set the sky color and the sky intensity. An intensity of 0 will totally disable the ambient sky lighting, and you will only have a direct sunlight. Sky ambient bounce is a strange option that allows you to slightly color the ambient light that affects dynamic models that are not inside of a Lightprobe volume, and that will make a lot more sense when I explain Lightprobe Volumes shortly. Finally, there's Skybox IBL source and scale. These two options override the sky color and sky intensity settings. To use these, you need to have your env sky set to have a name, and then set the name as your Skybox IBL source. So the ambient lighting will now be controlled by the actual material of the skybox and the skybox tint color here. There's a cool feature that allows you to quickly get decent lighting settings for your skybox. All you have to do is right-click on your environment lighting and go to selected entities, estimate lighting from HDR skybox, and it will dynamically update its position and lighting information based off of the skybox you have selected. This only works whenever you have a Skybox IBL source active though. The other 3 lighting entities by default will have baked direct and indirect lighting and have light indexing enabled. These are typically called baked index lights and can cast dynamic shadows and generally look somewhat better, as you can see here, than non-indexed baked lighting. Valve typically uses many dim non-index lights around the level to add a softer, more ambient lighting. And they'll use brighter index lights closer to light sources. The indirect lighting of all lights can be either always on or always off, but cannot be toggled, so this means if you have an index light that turns on and off, like this one does, you'll still have the indirect lighting present if it's enabled, like it is here. Non-index lights cannot turn off at all, so there isn't a reason to disable their indirect component. In fact, the indirect component of all lights is essentially just a baked non-directional light. Another important thing to keep in mind is that only 4 index lights can shine onto a single surface at a time. You can get a general idea of how many lights are active on a surface at a time in Hammer by enabling the 3D Tool View mode for baked lighting complexity. Besides baked indexed and non-indexed, there's also per pixel lighting. These act a lot like Source's projected textures. These are the only kinds of lights that can move around, but you can only have a single per pixel light that casts shadows active on screen at a time. You can, however, have up to 8 smaller per pixel light omnis that do not have shadows or speculars enabled. As you can see kind of the lighting around this object, it's used a lot in items that glow in Half-Life Alyx. But otherwise, per pixel lighting is not used very much, except for the flashlight. Now that you know about the kinds of lighting entities, let me actually show you how to work with the lighting. I'm going to make a new map, just a simple hollow box with a light environment. In Source, this map would simply be black, but in Source 2 you can see the environment light through the walls. This is because only the front faces of geometry will block light. That means light is able to shine right through the back of the face and into this room. The underground areas of Half-Life Alyx are all surrounded by a block light box to stop light from entering. Be careful when using block light that you don't use block light solid, because the solid version will generate Vis clusters just like a normal wall would. Solid block light is best used on things like roofs, where the player could throw an object but they can't actually see. Light spots and light orthos both can use something called a lighting cookie. This essentially controls the shape coming out of the light. By default, it's going to use the flashlight shape, but here's a list of all the available light cookies in Half-Life Alyx. My favorite one is probably the muzzle flash or Dirt 1. To get special effects such as HDR camera exposure, color correction, and light shafts, you should have a ENV tone map controller, a post-processing volume, and an ENV volumetric fog controller, all set to master for each of them. You should also give them all a name. The most important one, though, being the volumetric fog controller. This entity enables the volumetric fogging system that allows you to get good-looking lighting effects. To get better control of your volumetric fogging, you need an ENV volumetric fog volume, and you place this near your light source. As I mentioned previously, Valve likes to use a lot of dim, non-index lights to provide ambient lighting in the map. These same lights also have their volumetric fogging disabled. Valve also likes to place very dim, non-indexed lights right at light sources, but with very high fog contribution strengths. They then use a much brighter, indexed light with no volumetric fogging to cast most of the lighting and the dynamic shadows. Doing this will allow you to get extremely good volumetric fog effects from the lights without having to use it on this light that you have control over. Since I'm talking about fog, I might as well quickly mention the actual fog effects in Source 2. Besides Skybox fog, which seems like it might be overridden by the other fogs, there are two kinds of fog you can add to your levels: ENV Cubemap fog and ENV Gradient fog. Both of them can be used together. Most of the Half-Life Alyx levels use just ENV Cubemap fog. What this kind of fog does is it takes a cube map, usually of the Skybox texture, and uses that as the fog itself. This means distant objects will fade seamlessly into the Skybox, no matter where you're looking. This solves a long-time issue in Source with trying to match the color of your fog with your Skybox color. This entity also works a lot like the typical fog in Source. Gradient fog seemed to have a little bit more functionality in SteamVR, but in Alyx it still allows for a lot of cool effects like this height-based fog that hugs the ground. I'm sure you're familiar with Cubemaps, and they're essentially the same in Source 2, but this time they use a volume called a ENV Cubemap box. This is the same as a normal ENV Cubemap, but you have a box to control exactly what objects get applied to that Cubemap. So in Source 2, all dynamic objects, including NPCs and physics props, require an ENV Lightprobe Volume. This is another volume that works exactly like the Cubemap box, but instead of reflections, it creates an area that allows for very accurate lighting on dynamic objects. Here you can see two identical props. One is inside of a Lightprobe volume, and one is not. Watch how when this physics object enters the Lightprobe volume, the lighting changes. Static props don't need Lightprobe volumes, as you can see here. The lighting on this static prop is completely fine without a Lightprobe volume. Notice how even right next to this light, no lighting changes are made to the cone. Over here, inside the Lightprobe volume, lighting is perfectly applied when moving this object around the light. In fact, outside of a Lightprobe volume, dynamic props can only be lit by the sky color and per pixel lights. So each area the player can enter or see in a map should have both a Lightprobe volume and a cube map. Well, instead of using two separate entities, most of the time you should just use the ENV Combined Lightprobe Volume entity, which is just a cube map and a Lightprobe volume combined into one simple-to-use entity. These volumes can overlap each other, and you can set the priority of them or the voxel size, which is essentially how many samples are made within the Lightprobe volume. Areas inaccessible to the player should probably have lower resolution than areas that the player is going to be in. You may also have noticed my nice shiny balls of steel. This is simply a material I quickly made to help test the cube maps, but this has caused me to discover what I believe is some undocumented behavior in Source 2 or a bug. Sometimes when creating levels, these balls of steel will show up totally black. The cube maps are built and only a small specular sheen can be seen on the black balls. I have found many solutions to this issue, first thinking it was sky related, lighting related, mesh related, I still have not actually found the true cause of the issue or the solution, and trying to replicate the issue is just as hard as trying to fix the issue. I've had situations where simply moving my Cubemap one unit will suddenly fix the issue, moving it back will cause it to go back to black, and then moving it back to where it should be working now no longer works. I have had it work fine when compiling on fast mode, and then switching to standard will cause it not to work. In this very map, they were completely broken until I added this random brush over here, and then disabling this brush now, suddenly it still works. The moral of the story here is that without this custom highly reflective texture, you might not even be able to tell that your level has completely broken reflections. I would like to cover custom material creation in depth in the future when I get the chance, but till then, I'll show you the settings of this material I made. Here they are, very simple, just 100% metal, 22 roughness, a little bit red. Source 2 uses physically based rendering, so you can really get the nice shines going. So the last and possibly most important part about lighting in Source 2 are the light maps. Light maps are basically textures applied over top of an unlit surface to give them the lighting you want. Source 1 and 2 both use light maps extensively. In Hammer, you can change your light map scale just by setting the light map scale value here with the face edit sheet. Well, you can do something similar with the face tool in Source 2. You can bias the texture plus or minus up to 8 or minus 8. This little test map I have here has a non-biased face, -3, -6, and then over here, +3 and +6. The faces up here are all default bias. So in-game, we can go and run the mat luxels command to physically view the light map grid on each of our faces. You can see here's the default non-biased face, and then the ones over here are much lower versus the ones over here that are much higher. The higher light map resolution you have, the better the baked shadows will look. Instead of manually biasing all the faces in your map, what you should do is place down a light importance volume, or create a mesh that's textured with the light map player space tool texture. These both do the exact same thing, which is automatically biasing surfaces higher or lower depending on how far away they are from the volume. Surfaces closer to the volume or mesh will have a higher light map scale, and surfaces farther away will gradually lower their light map scale. Now that this map has one of these light map importance volumes, the entire map is affected, including our previously biased faces. So here's the one with no bias, here's -3, and here's -6. -6 barely even has a single luxel applied to it. Conversely, the +6 biased face actually still has probably better looking texture shadows than even the faces right underneath the light map importance volume. So as you can see, the light map importance volumes don't create a drastic automatic bias effect, but it's good enough for the majority of situations. Valve seems to like using the brushes with the light map player space tool texture applied to them, but no matter your face biasing or importance volumes, the actual scale of the light maps are affected the most by your compile settings. Which leads me, finally, into the final topic of the video, compiling. There's not actually a lot of compile options for Half-Life Alyx. You can enable or disable features, you can change lighting settings, but that's about it. When it comes to lighting settings, I would recommend always using at least 1024, as 512 will sometimes cause the compiler to suddenly quit due to it being too small for some surfaces. But that issue can also be caused by a face that's biased too low. A final compile, which has its light map resolution set to 2048, should look pretty much amazing for even geometry far away from light map importance values, but you can go all the way up to 16K in size, which is absolutely ridiculous and would take more than days to compile a even small map on. But it isn't just lighting that takes a long time to compile in Source 2. VIS is very fast for small enclosed maps, but once you start working with large open spaces with high amounts of VIS clusters that can all see each other, the time VIS will take is going to exponentially increase. Volumetric fogging is another computation that takes quite a long time, And here is one you may be surprised to hear. Sound will take quite a long time to compile in a larger map. Unlike in Source, where reverb effects were fully determined real-time by the size of the room you were in plus the Soundscape DSP setting, Half-Life Alyx pre-compiles accurate reverb data for the entire map. So in general, Source 2 maps take a lot longer to compile than Source. Even my 16-thread, 4 GHz beast CPU that can compile a quite complex Source map in a matter of seconds takes minutes when compiling even the simplest of Source 2 levels. And a larger map, hours to maybe days. It really feels like I'm back waiting for my very first Source maps to compile on my 2.7 GHz single-core Athlon in 2007. Now, I've tried for a while to get MPI working. I've tried various commands and setups, but I cannot figure it out at all. And of course, there's no documentation about this, or even the resource compiler. MPI is probably not even included in retail Half-Life Alyx. You can see the command line options have no MPI, so Valve clearly is using it. Why wouldn't they? If you don't know what MPI is, it's a system that lets you compile a map with multiple computers, so it takes a lot less time. So a lot of the info I've presented in this video I've discovered myself through hundreds of hours of trial and error. The Valve Wiki has very little good documentation on a lot of stuff. I suspect only a few people who probably work at Valve know the true inner workings of the VIS and lighting system, or what's actually happening during compile time. However, hopefully in the future we'll see some more mature documentation, but really, we're in the early days of Source 2 right now. Just like when Source came out, not much is known right now. Most maps people make will be silly test maps or basic creations, but Source engine levels today are absolutely amazing, and so much is known about the inner workings of every aspect of the Source engine. Yet new things are still discovered all the time. Imagine what Source 2 will look like 10 years from now. If you enjoyed this video, you should probably archive it because you never know when YouTube is going to go away. If you're one of the 6% of people who actually watch this whole video and are here right now, you should probably slap that sub button since you clearly like to listen to my voice. Let's get me up to 1,000 subs so I can do live streams from my phone in the middle of the woods. I'm Shy of Shy Studios, and I'll be back next week with a brand new video, probably recorded vertically on my phone. See ya.